You're standing on the surface of a world that, from a distance, looks almost exactly like home. Same size as Earth, same rocky body, same gravity tugging at your boots. For a long time, people called it Earth's twin. But the moment you step out of your ship, that twin tries to kill you in 4 different ways at once. It cooks you. It crushes the air into your lungs. It smothers you in poison. And somewhere far above, it's literally raining acid. This is Venus. And of every place in the solar system, this might be the one that hates you most. So let's do the unthinkable. Let's step outside and find out, second by second, exactly what would happen to a human body on the surface of Venus. For centuries, Venus was the planet of dreams. It's the brightest thing in our night sky after the moon. It's almost the same width as Earth, almost the same mass, made of the same rock and metal. Early astronomers looked at those thick, creamy clouds and imagined a warm, wet world underneath. Jungles, oceans, maybe even life. They could not have been more wrong. Those beautiful clouds aren't water, they're sulfuric acid, and they hide a surface that isn't a tropical paradise. It's the hottest planetary surface in the entire solar system. Hotter than Mercury, even though Mercury sits twice as close to the Sun. How does the second planet beat the first? One word: greenhouse. Venus is wrapped in a blanket of carbon dioxide so thick that sunlight gets in, but heat can't get back out. Over billions of years, that trapped heat built and built into what scientists call a runaway greenhouse effect. Whatever water Venus may once have had boiled away into space long ago. So when you imagine Venus, throw out the jungle. Picture instead a dim, orange, crushing furnace. And now picture yourself standing in it. Let's say your ship somehow lowers you to the surface intact. The first thing you notice is the light, or the lack of it. You might expect Venus to be blindingly bright. It's closer to the sun than we are. But that thick atmosphere scatters and absorbs the sunlight on the way down. So the surface is strangely gloomy. It's like a heavily overcast day at dusk. Everything washed in a dull, rusty orange. No sharp shadows, no blue sky, just a hazy, glowing murk in every direction. The ground around you is volcanic rock, vast plains of hardened lava, scattered with mountains and thousands of volcanoes, some of which may still be active today. There's no water, not a drop, not a puddle, not a single ice crystal. Liquid water cannot exist here. It would flash to vapor instantly. And the sky itself moves wrong. A day on Venus is bizarre. The planet spins so slowly that a single Venusian day lasts longer than its entire year. It also spins backwards. If you could see the sun through the haze, it would rise in the west and set in the east, taking nearly 4 Earth months to cross the sky. But you won't be admiring the view for long, because by now, Venus has already started killing you. The temperature on the surface of Venus is around 465 degrees Celsius. That's about 870 degrees Fahrenheit. Let's put that in perspective. That's hot enough to melt lead. It's hot enough to melt zinc and tin. If you set a block of lead on the ground next to you, it would slump into a silver puddle. Your oven at home maxes out around 260 Celsius. Venus is nearly double that, everywhere, all the time, day and night, pole to pole. The slow spin and thick atmosphere spread the heat so evenly that there are almost no cool spots anywhere on the planet. Now, here's the part most people get wrong. On Earth, 465 degrees of hot, thin air would still take a moment to burn you. You could feel an oven's heat and yank your hand back. But Venus's atmosphere isn't thin. it's incredibly dense. And dense, hot gas dumps heat into your body far, far faster than ordinary air. So you wouldn't slowly bake. The heat would pour into your skin almost the instant you were exposed, faster than your nerves could even register it as one clean sensation. Your outer layers would begin to cook immediately, and every breath you tried to take would scorch your throat and lungs from the inside. The heat alone would be lethal in seconds. But the heat isn't working alone. Stand on the surface of Venus, and the atmosphere presses down on you with about 92 times the pressure we feel on Earth. What does 92 atmospheres actually feel like? Picture diving deep into the ocean. For every 10 meters you go down, the pressure climbs by 1 atmosphere. To match Venus, you'd have to sink almost 900 meters underwater, close to a kilometer down, into the crushing black where no sunlight reaches and where unprotected human divers simply cannot go. That is the weight sitting on every inch of you the moment you step onto Venus. But, and this surprises people, that pressure alone wouldn't crush you like a soda can. Here's why. Your body is mostly water, and water barely compresses. As long as the pressure is even on all sides, your bones and tissues can take a lot more squeeze than you'd think. Deep-sea creatures live their whole lives under pressures like this. The real problem is what that pressure does with everything else. It forces the blistering hot, poisonous gas deep into your lungs with every breath. And it makes Venus's atmosphere behave less like air and more like a fluid you're standing inside. In fact, near the surface, the carbon dioxide is so hot and so compressed that it stops acting like a normal gas at all. It becomes what's called a supercritical fluid, something halfway between a gas and a liquid. So you're not really standing in an atmosphere. You're standing at the bottom of an ocean of hot, dense, toxic fluid. And you're about to find out what's in it. Take a breath on Venus, and you are not breathing air. The atmosphere is about 96% carbon dioxide. There is essentially no oxygen, none for you to use. On Earth, carbon dioxide is the gas you breathe out as waste. Even small amounts building up in a room make you drowsy and confused. Here, it's nearly everything, packed in at 92 times the pressure. Your body would have no way to get oxygen and no way to dump the carbon dioxide it's producing. You'd lose consciousness almost immediately from the lack of oxygen, long before the slower damage could finish the job. And folded into that carbon dioxide are nastier ingredients in smaller doses, traces of sulfur dioxide and other corrosive gases that would attack your eyes, your skin, and your airways on contact. So in those first few seconds on Venus, 3 separate executioners are already at work. The heat is cooking your skin and lungs. The dense atmosphere is forcing scorching gas into your chest, and the lack of oxygen is shutting your brain down. Any one of them would be fatal. Together, they don't give you a chance. But we haven't even gotten to the acid yet. High above the surface, between roughly 48 and 70 kilometers up, Venus is wrapped in thick decks of cloud. And, as we said, those clouds aren't made of water. They're droplets of concentrated sulfuric acid, the same kind of acid that can eat through metal. Up in those clouds, it rains. Acid falls in streaks toward the surface. But here's the strange, almost poetic twist. It's so hot lower down that the acid rain never reaches the ground. As the droplets fall into the hotter air below, they boil away and evaporate before they land, rising back up to form clouds all over again. Scientists call this kind of rain that never lands virga. So, on the actual surface where you're standing, you wouldn't be drenched in acid. The heat shields the ground from that. But make no mistake, if your descent took you down through those cloud layers, you'd pass through a sky full of corrosive acid mist on the way to a surface that's already trying to cook, crush, and suffocate you. There is no version of this trip that is gentle. Let's settle it. On the surface of Venus, what actually ends you first? It's a tie between heat and suffocation, decided in the same breath. The instant you're exposed, the dense, superheated atmosphere begins burning your skin and the inside of your lungs, while the total absence of oxygen knocks you unconscious. You would not last a single minute. Realistically, you'd be gone in seconds, overwhelmed before your body could even sort out which catastrophe was the worst. And we're not guessing here. We've actually sent machines to find out. In the 1970s and 80s, the Soviet Union landed a series of probes called Venera. These weren't fragile little robots. They were built like deep-sea submarines, armored to survive the pressure and the heat. And the longest any of them lasted on the surface before Venus destroyed it was just over 2 hours. 2 hours, for a spacecraft engineered specifically to take the punishment. A human in a normal spacesuit would last about as long as it takes to read this sentence. So Venus is a death sentence. End of story? Not quite. Because there's one surprising place on Venus where a human could almost survive. And it's not on the ground at all. It's in the sky. Climb about 50 kilometers up into the middle of those clouds, and something remarkable happens. The pressure drops to roughly what we feel at sea level on Earth. The temperature falls to a range a human could tolerate, somewhere between a warm room and a hot summer day. At that altitude, you'd still need oxygen to breathe and protection from the acid. But you would not be instantly crushed or cooked. It's so strangely livable up there that scientists have seriously proposed floating cloud cities above Venus, habitats drifting through the upper atmosphere, where ordinary breathable air would actually float like a balloon in the heavy carbon dioxide around it. The most hostile planet in the solar system, it turns out, hides one of the most Earth-like patches of real estate anywhere beyond our own world. You just have to stay 50 kilometers above the part that wants you dead. So, could you survive on Venus? On the surface, not for a heartbeat. It's the hottest, most crushing, most poisonous ground in the solar system. A place that destroys armored spacecraft in hours and would end a human in seconds. But float high in its acid skies, and Venus almost lets you live. That's the strange truth about Earth's twin. It's both the deadliest world we know and one of the few that might someday hold a human aloft. If you made it this far, you're exactly the kind of person who'd survive longest up in those clouds. So subscribe and stick around, because next time we're heading somewhere even stranger to ask the same question. Could you survive there?